in this video. Hello everybody and welcome to the 49th video on this channel. I know it's crazy, we are so close to the 50th video on this channel and that is going to be a great milestone, but for now I'd like to introduce our lesson. Before I do that, please make sure to like, subscribe, and hit that notification button for more awesome content just like this. And if you have any suggestions for this channel, please, and I'm begging you, please make sure you go into the comment section and comment any tips or tricks that I might want to include, and maybe another topic. So, without further ado, let's get right into it. Today's lesson is an introduction to trigonometry. As geometry gets more and more advanced, we are going to be using a few trigonometry theorems to prove things, and they will be a part of geometry. Now, I would like you to keep in mind that trigonometry and geometry are slightly separate. And geometry is a little more general than trigonometry. Trigonometry deals with the business of triangles and how their sides and angles relate to each other. Geometry is just general shapes and how their sides and angles relate to each other. But trigonometry does have a good amount of niche cases, so it's pretty much its own subject. But trigonometry is used throughout most of intermediate and more advanced geometry, so I would like to do a short introduction. This video and the next video will be two videos dedicated to trigonometry, so I'm giving you enough trigonometry knowledge for most of the geometry theorems. And if I ever need to explain a single topic for a different theorem or a different proof, I will definitely do that. One more thing before I start explaining, I'm going to start putting the proof and the theorem in one video. So instead of doing examples, answers to our previous questions, it's going to be the lesson or the theorem, an explanation of that theorem, and the proof of the theorem. Alright, let's start. So, as you can see on the very left, we have a right triangle with sides A, B, and C. Now, the angle is theta, which I have explained earlier, and if you want to know why it's theta, you can just go to our previous videos. But it's mostly just a symbol notation. It's a Greek letter, which is used to denote angles. And it's one of a few symbols used to designate angles. Like there's theta, there's phi. Phi is not really used that much. There's alpha, there's beta, there's gamma. There's a lot of different angles. And Greek letters used to demonstrate those angles. So our first function is called sine of theta. So sine of theta, the full spelling is S-I-N-E of theta. But we normally like to remove the E and have it in a short form of S-I-N. So sine theta is equal to A divided by C, where A in geometrical or math jargon is the opposite side. So if you see, C is the hypotenuse of the right triangle, and B is the side right next to it, which is called the adjacent side. So that leaves A, which is directly opposite to theta. So as a result, it's called the opposite side. The next function that I want to talk about is cosine. Cosine is C-O-S-I-N-E with theta, and that's the full form, but we normally abbreviate it as just C-O-S. This is the adjacent side divided by the hypotenuse. Alright? And that's pretty simple. And tangent theta is equal to A divided by B. And tangent, it's pretty obvious, but I'll just show it to you. Tangent is T-A-N-G-E-N-T, theta, and that's the full form. Now, there's one thing that's pretty interesting about tangent theta. Tangent theta, or tan theta, is equal to sine theta over cosine theta. So, if you simplify this, we get tan theta is equal to A divided by C divided by B divided by C. So if we look at it again, we have tan theta is equal to A over C divided by B over C, or times C over B. And when you factor everything, and this is A, not 9, we get tangent theta is equal to A divided by B. So that's essentially the derivation of tangent of theta. So it's really sine theta divided by cosine theta. And so but when you simplify it, you get a divided by b. Now there are actually 3 more trigonometric functions that are not sine, cosine, and tangent theta. The first one I'm going to talk about is secant theta, which is spelled this C-E-S-E-C-A-N-T theta, but we abbreviate it as SEC theta. This is equal to 1 divided by cosine theta. And similar to this, the next function that we're going to explore is cosecant theta. So this is pretty obvious spelling. We have co and then secant of theta, which is equal to 1 divided by sine theta. And we abbreviate this as CSC theta. Let me just quickly, CSC. Oh my, CSC. Cosecant of theta is equal to 1 divided by sine of theta. So now one thing that's interesting is normally cosine has the co prefix at the beginning, but secant is 1 divided by that. But cosecant is 1 divided by sine theta, which doesn't have the co prefix, which is actually quite interesting, and I just wanted to share it with you if you hadn't already observed it. So next, what we're going to do is the final function, which is 1 divided by tangent of theta. This function is called cotangent of theta. Cotangent of theta. Now, I've been using brackets to figure out cotangent or anything else, but you don't really have to use brackets for the trigonometric functions because the angle is always going to be pretty distinct, like theta or phi. So even if we have sine of phi, that's pretty easy. So you don't really have to use brackets, but it is a function, so technically you should use brackets, but you don't really have to. So cotangent of theta is equal to 1 divided by tangent of theta, and it is abbreviated as cot, C-O-T. So that's cotangent of theta. Now those are the 6 basic trigonometric functions that you need to know. So I think that's about it. That's all you need to know for the trigonometric functions. And it's pretty interesting. And there are a few basic rules that you'll need to know, but we'll get into that later. Or in another video. Sorry, not later. And now let's look at the right side. The right side is what we call a unit circle. Now, as you can see, I've drawn the triangle to show the vertical distance, the horizontal distance, and the hypotenuse. Now, as you move around the unit circle, you get something that's actually quite interesting. Well, it's not really that interesting. The triangle gets steeper because the angle increases. So I just wanted to share that with you, but that's not really the main purpose of the unit circle. The main purpose of the unit circle, as you'll see it in many trigonometry formulas, and also if you ever take trigonometry in high school, you'll probably see this come up. The unit circle will actually, let's just erase this triangle. What will happen is normally there will be increments of 30, so first let's just draw increments of 90, and then just split that into 3. I'm only going to do the first quadrant because it's easier. This would be 30 degrees, this would be 90 degrees, and this would be 60 degrees. And they would label the sine and cosine of each and every one of the angles. And the reason they're labeling sine and cosine is because those two are the most basic ones. And using those, you can figure out every other trigonometric function. So really, if you only had to choose 2 trigonometric functions to know by heart, you would definitely do sine and cosine because it's a lot easier. So it'll say sine and cosine, where cosine will kind of be like an x-coordinate, y-coordinate, so it will be written as this. Now I'll give you an example. The cosine of 60 degrees, and the cosine of 60 degrees is 1 divided by 2. So we'll have 1 divided by 2. And the sine of 60 degrees is the square root of 3 divided by 2. So what you'll see is it'll be 60 degrees and those 2 coordinates. Now, just so you know, the radius of the unit circle is always 1, as it's shown. If there's any visual demonstration online, like there's many videos which show like the triangle oscillating, the hypotenuse is always 1 because it's a lot simpler. So I think that's about it for trigonometry. Those are the very basics that you should definitely know. And see you in the next one. Bye-bye.